Hello everyone, this is M. Hemant Reddy. I am from Triple section. Today I am gonna say about the diversity factor and its effects of distribution from power system subject. Introduction to diversity factor. The diversity factor is a key concept in power system engineering. It is defined as the ratio of the sum of the individual maximum demands of a group loads to the maximum demands of the entire system. This factor helps in understanding how loads fluctuate over time and how they can be managed effectively. Importance of diversity factor. The diversity factor is a crucial for optimizing power generator and distribution. It allows for more accurate load forecasting and system reliability assessments. By understanding diversity utilities can reduce the size of generators and transformers, leading to cost savings. Calculation of diversity factor. The formula for calculating the diversity factor is dF equals to sum of individual maximum demands by maximum demands of the system. A diversity factor greater than 1 indicates that not all loads reach their peak time at the same time. This calculation is essential for designing efficient electrical systems and infrastructure. Types of loads. Loads can be categorized into different types such as residential, commercial, and industrial. Each type of load exhibits unique demand patterns and peak usage times. Understanding these patterns helps in applying the diversity factor accurately in power distribution. Peak demand and diversity factor. Peak demand refers to the maximum electrical load that occurs over a specified period. The diversity factor reduces the need for oversized infrastructure to accommodate peak demand. By considering the diversity factor, utilities can ensure better resource allocation during peak periods. Demand factor formula. Demand factor equals to maximum demand by connected load. Benefits of high diversity factor. A high diversity factor indicates that the load are consistently peaking at the same time. It leads to more efficient use of resource and reduced investment in generation capacity. Utilities can be operate with fewer reserves while maintaining reliability and service quality. Diversity factor FD equals to D1 plus D2 so on dn by dg. Challenges of low diversity factor. A low diversity factor may suggest that multiple loads peak simultaneously. This can result in a need for larger transformers and generators to meet demand. Low diversity can also lead to increased operational costs and potential services interruption. Applications in power distribution. The diversity factor is applied in the planning and operation of electrical distribution systems. It assists in determining the necessary capacity of transformers and other distribution equipment. By accurately modeling the diversity factor, utilities can improve load management strategies. Real world examples. In residential areas, the diversity factor is often higher due to varied usage patterns. Commercial loads like retail stores may show lower diversity during shopping hours. Industrial loads can contribute to both high and low diversity factors depending on production schedule. Impact of infrastructure design. The diversity factor influences the seizing of cables and other electrical infrastructure components. Properly accounting for diversity can lead to smaller, lighter, and lesser expensive equipment. This results in significant saving in both installation and maintenance costs. Regulatory and planning considerations. Regulatory bodies often mandate the consideration of the diversity factor in utility planning. Utilities must provide evidence of the diversity factor calculating in their resource planning reports. This ensures compliance with standard and promotes system reliability and efficiency. Future tense in diversity factor analysis. Advance in smart grid technology will enhance the accuracy of diversity factor calculations. Real time data analytics will allow for dynamic adjustments in load forecasting. This increased integration of renewable energy sources will also impact diversity factors in future scenarios. Conclusion. The diversity factor is a fundamental concept that affects power distribution systems significantly. Understanding and applying the diversity factor leads to more efficient and cost efficient power management. As energy demand evolves, the importance of accurately assessing diversity factors will only grow. Thank you.